So guys, we're picking up where we left off. Now we're going to be asked to find the fraction. So for us to be able to find the fraction, let's read the problem first. Based on reference table N, what fraction of the radioactive 90 SR sample which remain unchanged after 56.2 years? Once again, still using the same formula, N equals little t over big T. N being the number of half-lives, little t equaling time passed, big T being half-life. Now, me reading this problem, I know they give me time passed because they give me a certain amount of time after the word after. Now, they're telling me to go to table N. So when I go to table N provides me with my nucleotide, my half-life, my decay mode, my nucleotide name. Obviously, from this, I will be looking for my half-life. So SR90 has a half-life of SR90 has a half-life of 29.1 years. So, based off this problem, I have my big T and I have my little t. Once again, I'm going to take that information and plug it directly into my my formula. Now, with that being said, I don't know what n is, but I do know that little t is 56.2 over my big T, which is 29.1. When I divide that, I get n equals 1.93. Because I want to work with a whole number, not decimals, I'm going to go ahead and round that off to 2. So my n value equals 2. Now, I've answered the question, but they want it in the form of fractions. So my fraction base is always going to be 1 over 2 to the power of what? To the power of n. So I'm going to have 1 over 2 to the power of 2. The 1 in the numerator stays the same, but the bottom number, the denominator, 2 to the power of 2, is going to be different. So 2 to the power of 2 would give me 4, and thus my fraction is 1 over 4. So let's go ahead and let's try another problem. A radioactive element has a half-life of 4 hours. What fraction of the original sample will remain after 12 hours? Now, this problem is a little bit different from the other problem because there's no need for us to go to table N because they're giving us our half-life of 4 hours. I've highlighted that in red. I've written that in red. And then they also give us our time passed, which is 12 hours. I know once again because it says after 12 hours. So the word after and then an increment of time. So I have my little t and I have my big T. I can go ahead and solve for n. When I go ahead and do that, I don't know what my n value is, so I just put n, and then I know my my little t is 12, and my big T is 4. So 12 divided by 4, I get n equals 3. Now, because they asked for it in a fraction, I'm still dealing with 1 over 2 to the power of what? So 1 over 2 to the power of 3, because my n value gave me 3. The 1 on the numerator stays the same, but 2 to the power of 3 will give me 8, making my fraction 1/8. Now, the last type of question they'll ask is, what is the half-life? Like, remember before, I told you that the half-life is either given to you in the reference table or you have to solve. Some of the problems we've dealt with, the half-life has been in the problem. Some of the problems we dealt with, we've had to look on table N in the chemistry reference table to find the half-life, but now we're actually solving for the half-life. So it says, a 64-gram sample of germanium-66 is left undistributed after 12.5 hours. At the end of the period, only 2.0 grams remain. Calculate the half-life of this material. Once again, I am dealing with n equals little t over big T. My variables are not changing. My formula is not changing. What I'm doing after or before might be different. So, I know that they've given me time passed because I have time after 12.5 hours. I'm looking for this keyword after and then an increment of time. So that's my time passed highlighted in yellow. Now, they had to give me another piece of variable. They had to either give me n or big T. Now, because I'm calculating for the half-life, I'm not going to get big T. So that means they need to give me n, the number of half-life. Now, they've given it to you, but they've given it to you in a sneaky manner. And this is the manner. They're telling you what you're starting with, which is 64 grams, and they're telling you what you're ending with, which is 2.0 grams. So we need to find out how much half-life has passed from 64 to 2.0. So that's what we're going to do. So we're going to go from 64 divided in half, that's gives us 32. 32 divided in half gives us 16. 16 divided in half gives us 8. 8 divided in half gives us 4. 4 divided in half gives us 2. There's a slight little typo here. Now, slight little typo. And let's just fix that typo before we continue. So we've gone on and fixed our typo. So from 64 to 32, that's 1 half-life. 32 to 16, that's 2 half-lives. 16 to 8, that's 3 half-lives. And 8 to 4, that's 4 half-lives. 4 to 2, that's 5 half-lives. Now I'm stopping at 2 because it tells me that's I only have 2 grams remaining. I started at 64 because it told me that I had originally 64 grams. So that took 5 half-lives for me to get from 64 to 2 grams. So my n value equals 5. So now that I have my n value and I also have my little t, I'm going to go ahead and calculate for my big T. I'm going to take that information and plug it directly back into the formula. So I know my n equals 5, my little t equals 12.5. I don't know what my big T is, so I'm going to leave it there. And then I'm going to put a 1 underneath my 5, because what I'm going to do is I'm going to go ahead and cross multiply. So 5 times t is going to give me 5t, and 1 times 12.5 will give me 12.5. So then I have 5t equals 12.5. I'm going to go ahead and divide 5 from each section because my goal is to get big T by itself. So I'm going to divide 5 from both sides, and I get 5t divided by 5 gives me t, and 12.5 divided by 5 gives me 2.5, and that is my answer. My half-life is 2.5. So let's do this another problem. A 208 gram sample of sodium 24 decays to 13.0 grams of sodium 24 within 60 hours. What is the half-life of the radioactive isotope? Once again, still dealing with my formula. N equals little t over big T. Still variables has not changed. However, I know my time passed because it says within 60 hours. It's giving me an increment of time. I would be looking for my keyword after, but if I'm not, I'm going to look at other variations of that word after or between that time period. So they're giving me 60 hours. Now, they also give me a starting mass and ending mass, meaning they want me to find my n value on how long it took me, because they had to give me another variable. And because I'm calculating for big T, that means they have to give me another variable. Sorry for that rude interruption. Our teachers are having lunch. You can thank Ms. Roselle for that. All right. So now that I know my time passed, I need to figure out my n value because I am looking for my big T value. So I'm going from 208 to 13. So let's see what my n value is for me to go from 208 to 13. Remember, it's the number of half-lives. So how many times do I have to divide myself in half to get to 13 from 208? So 208 divided in half gives us 104. 104 divided in half gives us 52. 52 to 26 is 3 half-lives. 26 to 13 is 4 half-lives. So it took me 4 half-lives to get to 208 to 13 grams, meaning my n value equals 4. So now I have my n value and my little t. I'm going to go ahead and take that information and plug it into the formula. So my n value equals 4. My little t equals 60, but I don't know what my big T is. So I'm going to go ahead and put my big T as my variable that I'm looking for. Now, because I'm not aware of what process I'm going to be doing, cross multiplication usually helps me out. If I'm going to multiply, it easily multiplies. If I'm going to divide, it shows me what the division is going to be. So I'm going to put a 1 underneath my 4, and then I'm going to cross multiply. So 4 times t gives me 4t. 60 times 1 gives me 60. Then I have 4t equals 60. I'm going to go ahead and divide by 4 on both sides because I want t by itself. So 4t divided by 4 obviously gives me t, and 60 divided by 4 gives me 15. So my answer would be 15. 15 hours to be exact. When it comes to half-life problems, you need to be able to distinguish which method you're using. You're always going to be using n equals little t over big T, but you need to decide, am I going to take my grams that they gave me to find my n value first to solve for the unknown, or am I going to be using um, my little t and my big T to find for n, and then find out how much I started with or how much I ended with. So go ahead and use this video, pause it when you have to find out, to help you with your homework and to help you study for the exam. All right, if you have any questions, let me know. Thank you for watching, I guess. Bye.